Hello my dear friends, welcome to CAMS Engineering. In previous video we had seen how to create fill protection wall and its structural backfill, plus its structural excavation. Today we will see how to create retaining wall in cut condition using Autodesk Subassembly Composer. Before we go through the steps, let's remember some points about cut protection wall. In previous videos, we had already created our fill protection wall. Now let's see some highlights about cut protection wall. As you have seen the OGL, it is our cut retaining wall. It will be our insertion point. From our insertion point, we will determine our foundation level either from target or anchor depth. Next to that, we will see our top target if we have. The other thing is we call the wall side slope face to the road is front in fill case, but it will be reversed in cut condition. Again, we will have a drop for our maximum backfill height. The other parameters are almost similar with the fill condition. If you are new for my YouTube channel, please subscribe. Let's start. It has a lot of new techniques. Please see this video carefully. Since we will create our cut protection wall with the first fill case, we will edit here. First, we have to delete it. First, I will do auxiliary point. It is slope delta x and it starts from point 1. Its slope and delta x is 0. Sorry, we have to give to target parameters first. Our first target is fill offset target and give any preview value. Our second target is top target. Its type is elevation. Now we can continue. Its offset target will be our new fill target. We will define a variable. I call it dx. It's double. Its default value is ap8.x minus p1.x. Now we will have one interesting decision for either fill or cut protection wall. It is simple, but if AP8 opening parenthesis is valid and our new dx is valid between 0 and a number as per your requirement, and please correctly write the condition. See displayed condition on the screen. If this condition is true, our protection wall will be fill, otherwise it will be cut. Please create a flowchart for your new cut protection wall and give its name. As you have seen it, our fill target is less than 10. It is still in fill case, but when I changed the number to greater than 10, it will automatically change to cut condition and open your flowchart. Now let's give some input parameters. First, we will decide our condition, have ditch or not. Its type is yes, no. First, we will start from yes. Again, we give ditch input parameters. I think you are now familiar with how to create ditch using Subassembly Composer. If you are new, please see my previous videos about the ditch, so please follow the video steps. By the way, we have to give the display name because it is the only visible display on Civil 3D. Now make a decision if our case has ditch or not. Please correctly write or copy-paste. If it is true, insert a flow chart for our ditch case and open it. For the time purpose, I will only create U-shaped ditch, but please see my previous videos for other ditches. Follow the video steps. You can give shape code here, but I will give all codes finally in short method. If you need, please insert a cut retaining wall insertion point. Now come to the false condition that is without ditch. Change the default value to no and add a point. Here is one trick. Please change point number 42 to point number 41 to make them similar point. After this, please connect the two cases to one auxiliary point. Please move your bottom target below point 1. Its type is slope delta x. It starts from point 42. Its slope is vertical. Its delta x is 0. And finally, its elevation target is our bottom target. Assuming we have ditch depth. Define variable, give its name. I call it anchor depth. For cut, it is double. This default if condition
If
is
AP9,
nothing, but if
AP9
is
and
valid
P4
means
too.
if we have bottom
YAP9
target and the distance between
YDD,
point 42
P4
and AP9
YAP9
is at least greater than our ditch
add
depth, we use that distance. Otherwise, we will use our given anchor depth. Please see the display of condition. Now we will add a point. Its type is slope delta y. Its stats from point 42. Its slope must be negative. Wall slope back not front. Its delta y will be negative. Anchor depth cut. It must be reverse. Please give me some time. We will finish the difficulty now. Move the original ground above point 1 because it is cut condition. Now we will have for cases here. Please follow me. Now insert our first auxiliary point. Its type is slope delta y. It starts from point 43. Its slope is positive. Wall slope back. Its delta y is 0 and its elevation target is top target. When you move your top target, AP10 also move. Next, insert another auxiliary point. Its type is slope to surface. It starts from auxiliary point 10. Its slope is wall slope back. Its surface target is EG. Now we have these points on our top and bottom target plus on our existing ground. Now we will define a variable before that we will give to input para. The first one is our given wall height for cut condition. The second one is our allowable maximum wall height. Now come to our variable. Give its name. I call it wall height cut 2. Its type is double. Its default is nothing, but if we have top target, our wall height will be between our top target and bottom of the wall. Or if a P11 is valid again, our wall height will be between a P11 and bottom of our wall. Otherwise, it will be our given wall height. But we have also another condition here that is our allowable maximum wall height. Again, we will define another variable. I call it wall height cut 3. It is our final wall height. Its default means our previous wall height is greater our maximum. Our wall height will be our maximum height, otherwise it will be our previous height. Now we have got our wall height. Insert a flowchart and open it. After these, it is similar with our previous fill protection wall. Please practice it as per the video. Thank you very much. If you have any problem, please contact me via Telegram.